A cup with the shape of an inverted cone is being filled from a water fountain. If the cup has a top radius of 6 centimeters and a height of 12 centimeters, and water enters from the fountain at a rate of 36 pi centimeters cubed per second, at the instant the height of water in the cup is 6 centimeters, find the A, rate at which the height of the water changes, B, rate at which the radius of the top surface of water changes, and C, time it takes to fill the entire volume of the cup. The cup here is an inverted cone, and so it has a circular top to it, and that circular top has a fixed radius of 6 centimeters, so we can label it as 6 centimeters on the picture, and the height is a fixed height, which we can therefore label that on the picture as 12 centimeters. Water enters from the fountain at a rate of 36 pi centimeters cubed per second. Because of the unit centimeters cubed, that indicates a volume due to the length cubed. So that's a volume rate. So V prime, or dV dt, is equal to 36 pi centimeters cubed per second. That will fill water into the cup, and the water will have a certain height, which will change, and a certain radius, which will also change. I will label the height as y and the radius as x. Both of those will be changing as it fills the cup up with water. We want to look at the instant the height of water in the cup is 6 centimeters, so we will want y to become 6 centimeters, though we don't want to label it that way on the picture because y will be changing with time here, and only constants are labeled on the picture. We have a triangle within this cup. It's right here, which I'm going to draw to the side here so that we can investigate it a little bit closer. It has a 6 centimeter side, and it has a 12 centimeter side, but there's also a smaller triangle within it, the water, which has a height of y and a side of x. The small triangle and the big triangle have the same angles, and they are therefore similar triangles. And similar triangles have their sides in the same proportion. So if we take the top side of the small triangle over the height of the small triangle, it will equal the top side of the big triangle over the height of the big triangle. We can now cross multiply both sides by 12 and multiply both sides by y. And we can divide both sides by a 6 to reduce this down. And 2x equals to y. Since we are given a y value, and for part A we want to find the rate at which the height of the water changes, the height being y, we're going to want to solve for x in terms of y here, so x will equal to 1/2 y. Now our volume of water is sitting inside the cup will be the volume of the cone of water. And the volume of a cone is 1/3 pi times its radius squared. The radius of the water volume is x squared, times the height of the water in the cup is y. But we have a relation between x and y here, and that can plug into that volume equation, giving us 1/3 times pi times 1/2 y squared times y. So we have 1/3 pi, 1/2 squared, 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4. That'll give us a 1/4 times y squared times y. Now we can multiply the fractions with each other. 1/3 times 1/4. 1 times 1 is 1. 3 times 4 is 12. We have a pi, and we have a y squared times a y, which will be y cubed. There's our related variables equation, and we can take that related variables equation to find the related rates equation between those rates. We have the rate of the volume given, and we want to find the rate at which the height of the water changes, which will be y prime. So for part A, we will take that related variables equation and take the time derivative of both sides, indicated by a prime on both sides. Now every variable is implicit with time, so every variable will get a prime in the derivative. On the left side, the derivative of v will be 1, but then times v prime due to the chain rule. On the right side, we have a power rule. So we have the 1/12, we have the pi. We'll bring the power down, subtract 1 from it, and then multiply by the derivative of the inside, which will give us a y prime. The 1/12 and the 3 can multiply to become 3/12 or reduce down to be 1/4. And we have 1/4 pi y squared y prime. We can now plug numbers into this. V prime is 36 pi, and that will equal to 1/4 times pi times y squared, 6 squared, times y prime. Now instead of multiplying the numbers out and making bigger numbers, we can cancel numbers on each side. The 36 can cancel with the 6 squared, since they're both in the numerator, and the pi can cancel with the pi. Again, they're both in the numerator, leaving a 1 over here. So we have 1 equals 1/4 y prime, or multiplying both sides by 4, 4 equals to y prime. So y prime, or dy dt, the rate at which the height of the water changes, is coming out to 4. It'll be in units of y, length. Length in this problem is centimeters, over time, seconds. For part B, we want to find the rate at which the radius of the top surface of water changes. That's x. Now we have x and y related to each other right here. So using that related variables equation, since we now have the rate of y, we can take the time derivative of both sides of this, and that will give us that 1x prime equals to 1/2 y prime. So x prime is going to equal to 1/2 times, plugging the y prime in, 4. 1/2 times 4 is a 2, so x prime comes out to a 2. And therefore x prime, or dx dt, is equal to 2 units of x, length, centimeters, over time, seconds. There's the rate at which the radius of the top surface of water changes. For part C, we want to find the time it takes to fill the entire volume of the cup. Well, the entire volume is being filled at a rate of v prime for an amount of time t. So amount equals rate times time. The volume is 1/3 times pi times r squared times h equals the v prime times t. We want to fill the entire cup here. So we will be using the entire radius of the cup, which is a 6, and the entire height of the cup, which is a 12. And all this will equal to the rate at which it's being filled, v prime, which is 36 pi, and then times t. Again, instead of multiplying all the numbers out on the left side and getting big numbers, we can look to cancel some things out. Again, there's a 6 squared here, which will cancel with the 36. They're both in the numerator on each side. And then the pi's can cancel. They're both in the numerator on each side. And we're left with t will equal 12 times 1/3, which is 12 divided by 3. 12 divided by 3 comes out to 4. We're in time units of seconds here, so it'll take 4 seconds to fill the entire volume of the cup.